Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have a times of square root of a minus square root of a equals to 6, and we solve this problem for all the values of a. So the very first step we are going to do is first you see that square root of a is lies on both of these two values, so that we will be take common square root of a is equals to x. And so when we put square root of a equals to x, this implies that when we apply squaring on both of the sides, we get x square is equals to a. So it means that this a is equals to x square and this square root of a is equals to x. And further in the next step, we need more simplifications here. And when we substitute both of these two values to the given equation, it will be written as x square times of x minus x is equals to 6. And you see here we have x square multiplied by x becomes x cubed minus x is equals to, this is 6. We write this 6 as 8 minus 2. And in the next step, we again rewrite this equation as x cubed minus x is equals to, this is 8. We write it as 2 cubed minus 2. And in the next step, we move all the terms from right hand side to the left hand side, and it will becomes x cubed minus x minus 2 cubed plus 2, and this whole equation equals to 0. And here we combine these two cubic terms, and it will becomes here x cubed minus 2 cubed, and from these two terms we will take common minus 1, and we get the remaining values are x minus 2, and this whole equation is equals to 0. Here we use the nice cubic formula. So for this we know about that if we have uh, u cubed minus v cubed equals to u minus v times of u square plus uv plus v square. So according to this cubic formula, we write the left hand side of the above equation as in this form. So this will be written as x minus 2 times of x square plus x into 2 plus 2 square minus, here we have this is x minus 2, and this whole equation equals to 0. And further in the next step, we take common x minus 2 from here, and when we take common x minus 2, we get the remaining values are, from here we get x square plus 2x plus 2 square becomes 4. And when we take common x minus 2 from here, we get minus 1, and this whole equation equals to 0. And in the next step, we need a little bit more simplifications, and it will be written as x minus 2 times of x square plus 2x, and 4 minus 1 becomes plus 3, and this whole equation equals to 0. And now we divide this equation into the two cases. So the first case is we write x minus 2 equals to 0, and the second case is we write x square plus 2x plus 3 is equals to 0. From here we get x is equals to plus 2, and here you see that we just solve this problem for the real values only. We solve this problem for only real values, so that's why first we need to check that is this quadratic equation has real roots or not, so that we apply here the discriminant formula for checking the roots. And now we first write the coefficients of this equation, and its coefficients are a equals to 1, b equals to 2, and c equals to 3. And the discriminant formula is written as data equals to b square minus 4 times of ac. The value of b in this case is 2. We get here 2 square minus 4 times of a is 1, and c is 3. So you see here we have this is 4 minus 12, and 4 minus 12 becomes minus 8, and you see that this is clearly less than 0. So if our data is less than 0, this means that this quadratic equation has complex roots. Okay, So if this has complex roots but we need only real roots, so that we rejected this case and we will just proceed here this case only. So x is equals to 2, we move backward and we substitute the value of x here, and in the start of the problem we will take x is equals to square root of a. So when we put this x equals square root of a, it will become square root of a is equals to 2, and for the values of a we take squaring on both of the sides, and when we apply squaring, this 2 and square root are gone and we get a equals to this 2 square becomes here 4. So we have a is equals to 4 be the only one real root of the given equation, and in the next step we need to verify that is this value of a be the solution or extraneous root. So for verification of this value, we need to copy down given question statement. Here it is a times square root of a minus square root of a is equals to 6, and here we substitute a equals to 4 into the left hand side and we check its behavior. So when you put it here, it will becomes 4 times of square root of 4 minus square root of 4 is equals to 6 or not. We know about that square root of 4 becomes 2 minus square root of 4 becomes 2 is equals to 6, and 4 times of 2 becomes 8 minus 2 equals to 6, and we clearly get here 6 is equals to 6. This shows that both of the sides are equal, and if both of the sides are equal, this concludes about that the value a is equals to 4 is satisfied our given question statement. And finally we have the solution set of this problem is a equals to 4. So this is our final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.